Going on to topic 4 of chapter 7, we're going to be dividing radical expressions. And a major part, rationalizing denominators or numerators with one term. All right, let's get started here. Now, when you see a fraction like this under a radical sign, what it refers to is taking the cube root of 64, which in this case is 4, and the cube root of 343, and that's one I happen to know, and that's 7. So that was pretty straightforward. Take the cube root of the numerator, the cube root of the denominator. Now for this, again, we want to assume that they represent positive numbers. So the square root of 25 is 5. Now the square root of x to the 5th, we're going to be able to take out x to the 4th and an x that's left. So the square root of x to the 4th is x to the 2nd. And then what was left is that other x there. And then this is a perfect square. So this is just 2y. And here we have the 5th root of each of these. So I'll show it to you in detail. So we get a to the 5th times a to the 4th. This is the 5th root of that. And then the same thing on the bottom, the 5th root of. This is a perfect 5th, so we can leave it that way. Now c has c to the 15th, and there is one left over. That's just an extra one there. So when we simplify this, this is going to be a to the 5th. The 5th root of that is a, and then you have the 5th root of a left over. Well, the 5th root of a to the 4th left over. And on the bottom, we're going to have, this is going to be b to the 3rd, c to the 3rd, and you have the 5th root of c. Now theoretically you could put that all under one radical sign, and I'll have to check to see if that's how they have it. Yeah, that's how they have it. All under one radical sign. So we can just go like that. Okay. But remember, this is in the denominator. Now here, keeping in mind, as long as the index number is the same, we can go 120 divided by 5, and then now 120 goes into there, let's see, 24 times. So we get the square root of 24 here. 5 goes into there 24 times. But now 24 is the square root of 4 times the square root of 6. And the square root of 4 is 2. The square root of 6 is the answer for this one. Now again, we have this fraction out here, 4/5. But notice now, if we put this all under one radical sign, this becomes the 3rd root of 125, which is a perfect cube. The cube root of 125 is 5, so you get 4/5 times 5, and these 5's cancel out. So all we're left with from all of this is 4. We have simplified. And then here, all of this under one radical sign. And I think all our denominators can go into there, so let's put it this way. The fourth root, 3 goes into 21 7 times. Now this is going to be x, when we subtract 2 from 7, x to the 5th, and this becomes y to the 9th, subtracting the 1. So now we deal with that. So we're going to break that into 2 parts using the technique from the previous lesson. Now that doesn't go any, but this goes x to the 4th here with an x left over to get x to the 5th, and then we have y to the 8th with a y left over to give you y to the 9th. So these are perfect fourths. This will be x, y to the 2nd, and then the 4th root of 7xy. We're using some of the techniques we had in the previous lesson. Here we're just ensuring that we integrate this, but it must have the same index number to do that. Okay, now they want us to rationalize the denominator. But we have to do a little work here first. We're going to say this is the square root of 5. And this denominator, remember, is the square root of 4 times the square root of 2. What is the square root of 4? The square root of 4 is 2, the square root of 2. So now, what do we multiply our denominator by to get rid of our radical? We want to rationalize it. The square root of 2 is irrational. And I'll do it in blue. We're going to multiply this denominator by the square root of 2 over the square root of 2. And what did we say this was? A 1. The same procedure we've used throughout to get equivalent terms, fractions. We're using that technique. But notice what happens now. The square root of 2 times the square root of 2 becomes the square root of 4, which is 2. So in our denominator we get 2 times 2, which is going to be a 4. And our numerator becomes the square root of 10. So our denominator before, where it was irrational, now has become rational through this process. We have rationalized the denominator. So what do we need to do here? Now keep in mind, 8 is still, we can write it this way, 2 the square root of 2. That's what this 8 is. It was 4 times 2. We took the square root of 4, got 2. But our denominator now is 7a. And all of this is under the radical here. So what do I have to multiply this by to make it rational, to rationalize it? And I'll put it in red. And again, it's a 1 in the form of the square root of 7a over the square root of 7a. There's my 1. So this becomes 49a squared, which just becomes 7a. And now my numerator becomes 2, and then 2 times 7 is the square root of 14a. Now, nothing can cancel out here. If it could, we should do the canceling. Now, here we're doing something to the third power. So what do we have to multiply this by? It's going to be the third root of something over the third root of something. That'll make our denominator a perfect cube. Well, so far we have 5 times 5. If we multiply it by another 5, that makes it 125, which is a perfect cube. And we have y to the first, so if we multiply it by y to the second, that will give us a perfect cube for our denominator. But remember, we have to multiply this by 1, so we have to multiply the top by 5y squared. So my top now becomes the third root of 5x squared y squared all over 5y, because this became the third root of 125y cubed. This was a perfect cube. I took the cube root of this and got a 5, cube root of this and got a y, and that's my answer. Now in these next few, and I'll raise it up now, we can't quite see them, but you can look at your booklet and see them. Here they want us to rationalize the numerator. So I made that error when I was doing Math Lab. I kept rationalizing the denominator, and they said it was wrong. And then I had to read it correctly. They want us to rationalize the numerator. You'll be doing this in pre-calc, should you take that course. Okay, so this is 12. 12 is the square root of 4. Let me put it up here. The square root of 4 times the square root of 3. So the square root of 4 is 2 the square root of 3. So you could do this ahead of time here. And let me take this away there. So I need to multiply, and this is over the square root of 5. I need to multiply this so I can rationalize the square root of 3. So I'm going to multiply it by the square root of 3. And it has to be a 1, so the square root of 3 over the square root of 3. So this becomes the square root of 9, which is 3. 3 times 2 is 6. And this is the square root of 15. And this one here, again, we're dealing with the numerator. So what do we need to multiply that numerator by to make it a perfect cube? Well, there's already one 3 there, so I need to multiply it by 2 more 3's, which makes it a 9, and then a to the second, so that will be a to the third. And I need to do the same with the denominator. So 3, 9, a squared. Now my numerator is going to become the cube root of 27a cubed. 3 times 9 is 27. But the cube root of that makes it 3a. I've rationalized the numerator, and now I do the denominator, and I get the cube root of 54 a squared b squared. 6 times 9 is 54, but there is a perfect cube in there. So this is going to tease apart into the cube root of 27 times the cube root of 2a squared b squared. And what does this become here? Well, this becomes then 3a, and the cube root of 27 is 3. the cube root of 2a squared b squared. And this is the answer they give down below. But can I cancel out these 3's here? Yes. So the answer should be for this a over the cube root of 2a squared b squared. Whoever they have checking these answers made just a little error there, not too bad, because you've done a lot of work. And you know, if I were giving you a paper test, I'd give you lots of partial credit for this. Okay, we'll be going on to our next lesson shortly. We'll keep this one short.